Coulombs.com. In this video, we will learn about Coulomb's law and we will take a look at some simple examples. This law was first defined by French physicist Charles Coulomb in 1785 and was essential to the development of the theory of electromagnetism. Coulomb's law is a law of physics that describes the interaction between electrically charged objects. It quantifies the amount of electrostatic force that two charged objects exert on each other, which causes an attraction or repulsion between them. Like charges, for example two positive or two negative charges, will repel one another, and unlike charges, one positive and one negative charge will attract one another because of the electrostatic force. Specifically, this law applies to point charges. Any objects can be treated as point charges as long as they are very small compared to the distance between them. Also, the force is along the straight line joining these charges. We already know how to measure electric charge. This can help us calculate the electric force between charged objects. So, this equation shows the magnitude of the electric force between charged particles. F is equal to the product of the two charges Q1 and Q2 divided by the square of the distance between them r and then multiplied by the proportionality constant K. The electric force is expressed using the unit Newton. The reason why the distance is squared is because when the distance between objects doubles, the force between them reduces to a quarter of their original value. In other words, the electric force between two objects increases as the distance between them decreases, and opposite, the force decreases as the distance increases. The lowercase k is called proportionality constant or Coulomb's law constant. The value of this constant is dependent upon the medium in which the two objects reside. In case of air, the value of the Coulomb constant is 1 divided by 4 pi epsilon naught, which is approximately 9 times 10 to the 9 Newton meter squared per Coulomb squared. Epsilon naught is called the electric constant or vacuum permittivity. If we compare the Coulomb's law to the universal law of gravitation, we can notice that they have some similarities, but they work in completely different ways. The electric force is much stronger than gravity. From the equations, we can notice that they have different proportionality constants. In the equation for gravity, we are using mass to find the force, but here we are using charge to find the force. Thus, the gravitational force is always attractive, depending on the mass of the objects, which is always positive, and on the other side, electrostatic forces can be either attractive or repulsive, depending on the charges, so the result can be negative or positive respectively. To sum up, Coulomb's law states: the force between two like point charges is repulsive and between two unlike point charges is attractive. The force direction is determined by the line that passes through both charges. The magnitude of the force is directly proportional to the product of the two charges and inversely proportional to the square of the distance between the